Yeah. So good morning to all of you. I welcome you to this lecture 11. Uh, in today's lecture, we'll be discussing the following things: the group operator, the co-group operator, union and cross operators. We'll be discussing big functions category wise. We'll learn about eval functions and string functions today. And we'll cover both these case studies. We'll just, I'll introduce you to these case studies. We'll discuss a few queries with you, and then you will get it in your group today so that you can submit it as your lab machine exercises. Okay. And a few polls, of course, are always there. Now, why group operator? Because group operator is very important in almost all your queries that you're going to write. For example, if you're going to generate a summarized information from your relation or from your data set, then you require grouping. A lot of things would involve grouping in it. And similar to group operator is the co-group operator. We'll discuss that today. And union and cross operators, whatever you've learned in SQL are similar, only the way you write it here is different. And then functions, of course, functions would help you to do a lot of analysis. So we'll be discussing these functions and we'll be working with these functions on our data sets, right? So let's begin. uh, Let me just begin by asking Rohit Kumar Singh, can you unmute yourself? Nancy, you can lower your hand, please. Yeah. Yes, Rohit.
Hello, good morning, sir.
Good morning, Rohit. Can you tell us something like what is a group operator, what it does? I
So,
mean,
with the help of group operations, we can use aggregate functions with it,
okay, and
aggregate operations.
what does grouping do?
Sir, it organizes the data based on
Organizes the data, perfect. Based on what?
based on fields names, field
Based on
names.
field names. Okay. Anything else? It can only be organizing data on field names.
Mm,
All right, Rohit, good answer. Thank you.
okay, sir.
Uh, let's ask Mridul. Mridul, unmute yourself. So meanwhile, we have started the services. Mridul, are you there?
Yes, sir.
Okay,
Good
Mridul,
morning, sir.
good morning. Group by, as Rohit says, that it groups our, organizes our data on some fields. Is there something else that we can do with group by?
Sir, it is used to group data in one or more relation.
All right. What else?
By using by group operator, we can use aggregate functions too, and according to the field names.
Okay. So a good answer, but what I was looking for, I'll put it on screen now. You can see that group operator organizes relation data into groups based on specified field name. So we can group either by a field name, or we can group on the entire relation also by using the all field, right? And some other things are there in the syntax, like using collected, merge, partition by. These are when you're working in an actual cluster and you are managing your jobs and you're setting the number of partitioners and reducers. So I won't be discussing it here since we are working on a single node cluster. All right, but I've written the meanings. You can take a snapshot of this slide, and I've written the meanings. You can read them out, right? So we'll be focusing mainly on group relation name, either by field name or group relation name all right. So what it does, it organizes our data into groups based on specified field names. So if we are grouping our relation on some particular field, so it would, you know organize it, it would group it based on that field, right? And how, what it does with that, just have a look at it. uh, it produces two fields of data. Whenever you use a group operator and a new relation is generated, then that relation consists of two fields. One of the fields is named as group, and the other one is a bag which contains all the columns and rows from the relation that you have used. Okay, so remember, the group operator produces two fields always. One is a group and one is a bag. The group operator would give you one field named as group itself. Okay, and the second one would be a bag. Bag is a collection of tuples. And that bag would contain all the columns from your relation on which the grouping has been done. And for example, if we load a relation employee.csv, okay, and we group it by department number, all right, then if we describe the new relation, we'll see that one of the fields is group, which takes the type of whatever type is of dno, that is our int, and the other one is a bag. The name of the bag is the name of the relation on which the grouping was done. So here you can see grouping was done on m, right? So the bag name is m, and it contains all the columns and the tuples from the relation m. Okay, and how the grouping is done, like if you have done a grouping on a single field, say D and no, right? So all the unique values would form one group. So for example, if there are three department numbers, say 10, 20 and 30, then there would be three groups: a group with the name as 10, a group with the name as 20, and a group with the name as 30. This is about, when you do group by field name. Now, if you use all instead of by, then you can perform aggregate functions or aggregate operations on the entire relation, right? So all would make one group, okay, and with the name as all. Instead of group, the name in the resulting relation would be all, right? So this is regarding the group operator. So let's work systematically today, since we are going to work with our employee and the department case studies also. So let's first load our employee relation, uh, giving it a suitable schema, right? So let's ask somebody here. Uh, let's see. Yeah, 274 roll number, Upinder. Unmute yourself, Upinder.
Yes, sir. Good morning, sir.
Good morning. Upinder, help us to load this relation. We'll give it the name as M. The name
Yes,
of
sir.
name of the file is emp.txt. What should I write here?
Uh, so load.
All right. Go ahead. Go ahead.
Sir, file name.
You're not using a proper mic.
Sir, I'm audible.
I'm muting you, Upender. The mic is not okay. So things like that, if you're not using proper equipment, you won't be able to interact. And obviously, I won't know whether you know it or not. So that would be a problem with whatever I talked earlier today, right? So Navneet Kaur can unmute yourself. Yeah, Navneet, unmute yourself. 263 Navneet Kaur. Unmute yourself. So Navneet is not attending the meeting. Fine. All right. Then let's see. Paras Kumawat, unmute yourself.
Yes, sir.
Paras, what to write here? Help me load the emp dataset. Yes, Paras, I'm waiting.
Yes, sir.
See, you are not aware of the basic load operation, Paras. That's a problem.
So load file name.
File name is emp.txt. ऐसे लिख
Yes,
दूं?
sir.
Just write like this. ऐसे लिखना है?
emp.txt.
ऐसे लिखना है? Look on the screen and tell me. You're not aware. See?
So using say in inverted commas single
Using
pig store
pig store,
comma
right? Using pig store.
pig storage
Achha, okay.
in parentheses commas
Okay, help me, to give a schema to it.
Age, roll number.
एम्प में रोल नंबर कहाँ है?
Sorry, sir.
Hmm.
Employee number, salary.
You're not aware, you're not aware of all the columns in the M table. एग्जाम में भी ऐसी क्वेरी आ सकती है, याद रखो, where you need to remember what are all the column names. So I'm writing the schema now. Okay, emp number as int, ename as char array, then we have job as char array. Okay, what else is there? Job, and then mgr number is there, I suppose. Mgr as int, then sal as float. How many are there? One. Yeah, I think one we have missed here. Should be higher date. Higher date as char array, sal as float, com as say int, and department, we can write DNO for department number. Department number as int. So see, we have given the schema for this. Our emp relation, which is loading the emp data set using commas as a separator, and we have given each field name a name and a type. Okay, if we don't give field names and types, then we can obviously use the notation of $0, $1, so on, and all the fields are of the type byte array. Once we do this, yeah, there's some problem somewhere. Where have we made the mistake? So Mani wants to tell us something. Yes, Mani?
Yes, sir. We are not in the grunt shell.
So we're talking a lot and we have not started pig. We have wasted a lot of time in writing this. Let's see if we can pick it up and copy it. So let's use describe. And yeah, so we have got the relation. Thank you, Mani.
Thank you, sir.
So we can see here, that would be the first step here, that we have given the relation schema so that it can help us. Now let's do the group operation first, then the co-group, then cross, and then union. 4 operations we'll do first, then we will discuss our first case study, and then we'll go with the functions, right? So I'm using a relation name A is equal to, look very carefully, those of you who have not understood or having issues with the grouping, because once you understand it, most of the queries would be easily done. So group X by DN. So I'm making a group on the basis of department number, say DN. Yeah, it's M, I suppose. We'll take a proper name from today. Group M by department number. Okay. So if I describe this for you, if I describe A, look carefully whether it is the same whatever we have learned. So we have the relation A is having one field as group of type int, and the next one is a bag. See, the name of the bag is M, and it contains all the columns from your M relation. Okay, so let's now dump A. So how many groups would be there in relation M? There are 3 departments, 10, 20, and 30. and one of the employees, if I just dump M for you so that we can discuss properly, we'll see that there are 15 rows, remember, in M. 14 are with departments, one is having a null department. See for the records on the screen now. So we have all the records belonging to some department, but the last one with the employee number 1234, name Ajay, is not allotted to any department. So a department null is there. So if I dump A here, there will be 4 groups, group 10, 20, 30, and a null group. Okay. So see for yourself. Now we have data grouped on the basis of department number. इसको अच्छे से देखना आपने, whatever you see on the screen now. There is a department 10, you can see one group, and all the employees who belong to department 10, all the rows are here. So 2 rows are there, right? Then 20 and then 30, and then in the last you can see there is a null also. Okay, so null is a single group. Whenever you have null values and you're doing grouping on that particular column, so it would be a separate group, the null values. Now if I want to count, say, how many people get commission, right? So I've discussed this query before also. Basically I want to differentiate between count and count star, right? So if I want to say find all the employees who earn a commission, department wise, I want to see how many employees earn commission. So what should I write here? Somebody to respond, please. What query should I write here? I want to display department wise count of people who are earning a commission, right? Certain people are not earning commission. The name of the commission column is COMM. So grouping has already been done on DNO. So can you suggest a query here, how to go about it? Yeah, waiting for your response. Don't just sit like that. You need to project something. Mani, you've already answered. You can lower your hand. We'll ask you later on. Yes, others are not there. This we are discussing for the second or third time this group operator. So if you don't understand it, it would be difficult for you to do any of the case studies, that I can tell you. आप कोई भी case study नहीं कर पाओगे if you don't understand this group operation. Ms. Narinder Pal, unmute yourself.
Yes, sir. Good morning, sir.
Good morning. Narinder, give me an answer for this query that I've asked you.
Sir, for each A,
Okay.
for each A, generate a group. You have it.
What's the problem? क्या प्रॉब्लम है इस क्वेरी में, बताइए. आप इसको याद करेंगे बाद में नरेंद्र. This is the query which I'm asking. Simple.
Yes, sir.
From the group relation, there are 2 columns in there. One is a group, so I've written group here. Another one is a bag from which we can generate summary information. So from that bag, I want to know count how many commission values are there. This count function will count only the non-null values. So if any tuple there is having a null commission, it won't count that. That is how count works. Okay. So if you
Yes, sir.
dump Q, you will see the output as, see, in 10, 20, 30. So in 10, nobody gets a commission. In 20, 3 people get commission. In 30, 4 people get a commission. And one null department, that is one person is getting commission there. Okay. So total you can count 8. So if you're interested to count null as well as non-null, then you can write a count star here. Count star counts the null values also.
Yes,
So
sir.
if we use this and we dump, you will see a changed output now. So you can see now the department 10 has 2 people. So this is the total number of employees in each department, right? So to count this, like I'm checking for commission column, I can go about this in this way also. I can just write here to count the total number in the, if I need to count the total number of rows, tuples in the bag, then I should write just count and then m. And then I'll get the same answer as 10, 2, 26, 36 and null 1. Okay, so I hope you have understood the differentiation between count and count underscore star. Count would count only the non-null values from a field or a column of a relation, whereas count star would count null values as well as non-null values, right? So this is one of the examples. We'll come to some when we discuss the case study. Now let's discuss about co-group operator. Co-group and group are similar. Okay, the idea is similar. Only that usually a group we use on one relation and co-group we use on two relations. So let me load the other relation also, the department relation. For that I can write this department.txt using pig storage as, let's give it a schema here, as dno int bname char array and location char array. Okay, let's give it this and let's dump to see whether it has been loaded properly. So this is our department relation. So we have loaded both the relations. Now let me just group them together using the co-group. Okay, that is the emp and the department on the basis of DNO. So the syntax would be, say, I can just take a relation name as, say, CG for co-group. CG is equal to co-group emp by DNO department by DN. Okay, so that this is the syntax, co-group, then the relation name by field name and comma relation name by field name. So I'm co-grouping them, two relations emp and department on the basis of DN, right? So if I dump this CG relation, just see how the group results or the co-group results appear. Okay, so you can see here department 10, then we have values from the emp relation and we have the values from the department relation, right? We'll be using certain functions based on co-group. So understand how what it does. It picks up, makes a group on basis of DNO. So one group is 10. Then it picks up all the rows from the relation M which are having department number 10 in it, and the same for the department table. Okay. So similar to the group operation, only that two relations are involved, two or more relations are involved here. Okay. So this is co-group. All right. We'll use it after some time in some of the functions. We'll see what benefit it provides. Then next is the cross operator. So as you've learned in SQL, the cross operator, okay, is a combination of each row from relation 1 with each row of relation 2. So it combines this cross operator. It combines each row from relation 1 with each row of relation 2. So we are discussing here the cross operator, right? We are discussing the cross operator here. So for that, let's pick up these emp and department tables. So the syntax would be simple. Let's take a relation CR is equal to, just write here, cross emp comma department. That's it. This is the cross operation. So similar to whatever you learned in SQL, the idea is also the same. The output would be on similar lines. So if you dump CR, remember emp has 15 rows and department has 4 rows. So if I dump CR, how many rows would be there in CR? Can somebody tell me how many rows would result in CR? They are on the screen. I don't know what's the count. Okay, so Ritika has raised a hand. Yes, Ritika.
So 60 rows will be there.
Yeah, 15 rows are in M, 4 in department. So each row of M would be matched with each row of department. So 15 into 4, 60 rows would be there. So Ritika, are you there with me or have you gone? Okay. You don't mute yourself unless and until I tell you. Yes, Ritika, unmute yourself.
Yes, sir.
Ritika, I want to count how many are there. ये तो ऊपर चले गए screen पर. So help me to how I can check how many rows are there in CR.
So we can count by CG, count CG.
It's not that simple, Ritika, that you can apply count. You see, count is only when
Yeah,
you group. You've not
yes, sir.
grouped it. This is a simple relation. Okay. So let's ask Ritik. Yes, Ritik, unmute yourself.
Good morning, sir.
Good morning. Ritik, can you help me to count how many rows are there? How many tuples are there in this relation CG? How I can
Sir,
find?
I think by applying count functions.
Count function can be applied only on grouped relation. This is a simple relation.
So if we rank it,
Rank. Rank is a very expensive task, Ritika.
okay.
And on what basis would you rank it? Do you have any unique values here? Look carefully.
No,
There's a
sir.
there's a repetition. So rank कैसे होगा? Similar ranks आ जाएंगे. Somebody else to discuss this with me? Money, money, money. Okay, go ahead, money. Just money, unmute yourself. Money, unmute.
Yes, sir. Sir, we will store the relation into file.
Very good. So we'll use a store operation here. Store CG into say something like O1, something like this. Say K1. Okay, and a folder with the name of K1 would be created. Okay, but we would be interested in looking on the number of records stored, so that would appear on the screen itself. You
Yes,
remember,
sir.
you know, that is displayed on the screen itself. So you can
Yes.
see on screen, it will come soon, that there are 60 records stored. Was it correct one? Did we use the same name? No, we used co-group, sorry. We should have used CR, okay? CR. So we'll see CR will have 60 records in it. These are the small things which, you know, while you are analyzing huge data sets, you can just check on these things, okay? So you can see here, right? Successfully stored 60 records. So that is one way of calculating the records. All right, Mani, thank you.
Thank you, sir.
So this is our cross operator. Next we have the union operator. So union is like whatever you did in SQL. Union is a combination of rows from two relations, including the duplicate values. Okay. So let me locate some files here so that I can show you the union operation. Or what do you say? What is the necessary thing for union? I say it's similar to SQL union. So can somebody tell me what is the necessary conditions or what is the necessary requirements for you to perform the union operation? Now you can raise your hands to answer this question. No one is willing to answer. I'm asking how we can perform the union operation. We can perform it on any relation. Like, can I write something here like say I take the relation UN is equal to say union M comma department. Will it work? Okay, let me begin by asking, will this operation work? Yes or no? I need to combine two relations. Union is a combination. Okay, let's ask Guleen. Yes, Guleen.
Yes, sir.
Will this work, Guleen? Just make a guess. If you're not remembering the union of SQL, there was something known as domain compatibility that we learned in union, intersection, difference operators in SQL. All right, let's ask Shaurya. Yes, sure.
Good morning. So,
Good morning, Shaurya.
sir, good morning, sir. So, two necessary conditions हैं हमारी जो उनका जो ये जो field number है वो equal numbers में होने चाहिए जो fields हमारी उनके in same order में.
Or what
और
else?
sir, data types जो field है should be in the same compatible with each other.
Okay, fine. So that is the thing. It should be, the compatibility as far as number of fields and types of fields is there, should be there. That is the
Same.
correct answer. Yeah. All right. So let's look for some files. Let's look for some files. If we do this, okay, and if we dump this, let's see what happens. We should see things also, whether this is feasible or not. See, the union has been done, right? But it is simply, it has just, because there is no fun in doing this union. Even though it will work here, there is no fun, because we won't be able to extract meaningful information, because these two relations, just by listing their fields, union would be just listing their fields. But for proper analysis, we'll be using union, where we are merging two or more data sets with similar, attributes, similar number of attributes and similar types. Only then we can draw relevant information out of it. Okay. So let's list some of the files here. I did make some files in the previous class. Say Z1 and Z2. Let's list them. That should help us, I think. Yeah. Z1 and Z2. So these are the two files containing three fields of roll number, name, and marks. Okay, and I have put some common fields also, common tuples also. One tuple is common, so just as to show you that it can contain duplicates. So I'm going to load these files now in Z1 and Z1. So Z1 is equal to load z1.txt using pig storage. And then the other file z2, and then I can do a union operation here, union z1 comma z2. Okay. So if I dump now, how many rows would be there resultant? You can see there would be total 6 rows, 3 from z1 and 3 from z2, and even if there are duplicate rows or tuples, they will be there in z3. So that is the idea about union, and then you can derive some meaningful information after the union operation. You can see the duplicate values are also there. It is simply putting one relation and at the end the second relation, and duplicates can be there. Okay, and based on this further you can extract information out of it. So time for a quick poll, all of you. The first one is very easy, should be able to do it, most of you. The poll is in front of you now. Limited time, please. Okay, 10 seconds more. 5 seconds more. I'll close in 5 seconds. So I'm closing the poll now. So close it. 96% of you are correct. 15 into 4, 60 tuples. One person is still adamant on 19. One person doesn't know. Maybe he's not interested, or he's not doesn't want to apply his mind here. So most of you are. Just I'm sharing the results with you. Next poll. It's on the screen now. 10 seconds, no. 10 seconds now. I'll close in 10 seconds. 5 seconds. Yeah, I'm going to close the poll now. So sharing the results with you. Average function includes null values in its operations. No, you see null values are not included. So if there are, if you are say adding commission from a department and out of 10, 5 are getting commission and 5 are not getting commission. So the total divided would be by 5, not by 10. So null values are not included. So false is the correct answer. Okay, 48% are correct and 48% are wrong. That's a good correlation here, right? So remember, AVG function includes null values in its operations. That is false. Okay. Okay. Now let's show this thing to you so that you are not confused, and then we'll discuss a few functions, and then we'll start with the case study. Average function. So we already have x, right? Remember, we have our x function relation with us. The emp, oh sorry, the emp relation. Yeah, the emp relation is there. I'm going to group it on department number once again. Okay, so A is equal to, note carefully all of you, group x by dn. Again, the x factor is there, right? We have been using x a lot. So group emp by department number, right? And now let's generate some summary information like the average. Okay, so for each A, generate group comma AVG. What is the commission column? We have named it as com, so it should be m dot com. Let's first see what output it gives, okay, and then we'll discuss your poll question here. I don't know whether we can make it. So just note this thing on your copies right now, the result that we have got, so that I can discuss with you. Department 20 is having an average commission of 200 and department 30 is having an average commission of 575. Note these two things, right? Department 20, 200. So we'll check department 20. It says department 20, the average commission is 200. I'm going to dump the emp relation so that we can see the rows. Now look for the commission in department 20. See very clearly the first employee is having a null. So one null is there, another null in department 20, then another null in department 20, then we have 300 in department 20, 200 in department 20, 100 in department 20, right? So 300 plus 200 plus 100 is 600. 600 divided by 3, not by 6. That is the total number of people in the department number 20, but only 3 are getting commission, 3 are not getting commission. So this 600 gets divided by 3, not by 6. So nulls are not included. All right. So this is about this average function here. Let's go further now to our next slide here. Yeah, the eval functions. Some of them you've already done and some of them we'll discuss. Say for example, sum function, count underscore star, average, max, min. This we have already done, but we can do it again now. So let's do these max and min, right? Max and min. Let's discuss this on emp table. The max and min, these are known as eval functions, right? These are eval functions in pig. And already we have a grouping on A. So let's have a projection here. Let's not waste time. Let's write here sum. Let's work on salaries. Sum sal. max emp dot sal, min emp dot sal, average emp dot sal. Okay, let me add here the number of employees also in each department, so that you can have a clear picture. Count emp dot sal. So I'm from the group that I formed, you know, the relation A is the grouping of emp on department number. I'm calculating the total number of employees in each department, then sum of the salaries of the department, maximum, minimum, and average salaries. We do have a M, we don't have a sal. Some problem here. Yeah, we have a comma here. Seems fine now. Yeah, we put a comma in somewhere, so we have corrected it. And let's dump this now, dump B for each A, right? Like, let's see what output we get for this, and I'll show the query at the bottom also. So you can get see the summarized results. This was the query that we wrote. So in department 10, total employees are 2, total salary is 7450, maximum is 5000, minimum is 2450, and average is also there. So you can see that for all the departments. In the null also we have a salary of one person is there, right? And 4500 is the salary, and that is the average and min max also. So that is how we can work with these eval functions. Okay, so we also know the difference between count and count underscore star, max min. Now let's see what this size operator is. This is a good one. Okay, let's see the size operator here. So for that, no, let me just open here. Yeah, let's see the size operator here. Here we have the size. It will compute the number of elements based on any pig data type. Okay, so it will compute the number of elements based on any pig data type. So let me just use size first of all before we actually see what it does. The definition I've told you, it will compute the size of the elements based on the pig data type. So different data types will have different sizes. Okay, so let's check that size. Let's again use a projection like the one we used. So I'll simply write here you don't need a group here. So I'm using the size function for you. Using the size function here for emp number and sal. Okay, I'm generating what are the sizes of the columns sal and emp number. So let's, what's there? Yeah, there is another comma here. Okay. Yeah. So from the emp table, I'm generating the size of sal and emp number. Okay, let me dump this now. From the answer that we get, we'll further continue our discussion from that point onwards. So both the sizes are coming as 1 and 1. Okay, see, I'm going to describe this for you. Describe emp. See emp now. We are and we listed this size of sal. So sal is float, right? Size of emp number. Emp number is int. So we are getting 1 and 1 as the sizes. Okay. Uh, Let me add something more here. so that you can understand it fully. Size of job, that's it. And let's now dump P, then we'll discuss about what it actually does. See now, okay, I use this query. I generated a size of sal, emp number and job. Sal is float, emp number is int, job is char array. So you can see for int, float, double, the size always returns 1. Okay. For char array, it will return the actual size of the data. So for clerk, it is returning 5. For manager, it is returning 7, and so on. Okay. And for byte array, it will return the number of bytes. Now, if you look at this definition, I think you can have a better idea here. There's a table there. You can have a snapshot of this table. Okay. So int, long, float, double, for all these types, the size function returns 1. For char array, it will return the number of characters in the array. For byte array, the number of bytes in the array. For tuple, bag, and map, the values are there. Okay. So that is how the size function works. All right, so this value, this is the size of job. So this particular row, maybe this is a clerk, so it is coming as 5. Okay, this is, I suppose, salesman. 8 is salesman. 9 would be what? President, I suppose, right? Okay. If you have understood the size function, you can give me a raised hand, please. If you have understood what it does, all right, fine. Let's once again go to this. Let's see now the concat function, right? We're going to see the concat function. So it is used to concatenate 2 or more expressions of same type, the concat function. So let's see a description here of concat. Okay, so you can give the expression separated by commas after the concat function. So let's see the usage here. We have what? Okay, the description is there. All right, simple as your string concatenation is there. So what we can do here is we can use concat directly. So this generate concat, and we can write here ename. Let's see if we can have a concatenation like this, and then job. Let's see whether it works or not. So I'm concatenating ename and job and putting a hyphen in between them, right? Need to check whether it works or not. So let's see whether we get this concatenated, the name and the job combined together with a hyphen. Yeah, so we can get it like this. So concatenation is, you can concatenate, I think most probably the strings. Let's check something else here, whether it does for other data types also or not. For int, let's see. So only for strings we can do, right? Or maybe just a second. It is emp number, I suppose. Okay. So we don't have this for any other data type, so is only for strings, the concat, right? And let's go here and see. Another one is subtract. Okay, so let's see this subtract function from here. So to subtract 2 bags, okay, it takes 2 bags as inputs and returns a bag which contains the tuples of the first bag that are not in the second bag. Okay, so I think we would be requiring some co-group here. Let's see. Yeah, we require a co-group here. So I'll take the similar data that is here. in these files. Okay, if you all of you can see my screen and you can hear me, because there are many long pause from your side. You can raise your hands if you are yeah. So we are discussing subtract. For this, there are two basically subtract is it will be comparing two bags, and it would be picking up values which are present in one bag and not in the other bag, right? So these are the two files that it is taking, m underscore sales, okay, and m underscore bonus. Two files are there. It loads both the files, and then it co-groups them, and then uses a subtract. Let's do that. Okay, I think I've got the files with me here. Something like this. Yeah, qq1.txt and qq2.txt. Let's list these files. You see, to see certain functions, we need some illustration. So that's what I'm doing. These are this is the one file. The employee serial number is there, employee name is there, age is there, salary is there, and the department is there, right? There's some text file here. Similarly, let's load this file. It's now the other one, okay, and this includes the bonus details, I think. Okay, it includes some bonus details. So these are the two files. Let's first co-group them. Okay, let's first load them, obviously. So say AA1 is equal to load. I put these files in the distributed file system also, so should work here using pig storage. Similarly, for this file QQ2, loaded in relation AA2, and then say CC as co-group, co-group. I'll co-group them, these two relations, and store the result in CC, right? Where is the problem now? Kindly locate the problem. Where are we doing it wrong? Mani is very careful with that. Yeah, Ritika. Okay, Ritika, tell me what's wrong.
So we can co-group by a field name.
Okay, very good. So all of you are very attentive today. But we don't have any field name, Ritika. Ritika ने pause कर लेती है फटाफट, right? Co-group AA1 by this and AA2 by $0. Let's hope it works. अब क्या करें आगे? You see, we want to see the subtract, the illustration for subtract. So we can co-group, okay, and then subtracting one relation, we'll just write this relation and generate subtract and then the two relation names, and I'll tell you what the output would mean. That could be on a clear screen. Say BD is equal to, for each CC generate subtract. Okay, so this is the syntax. Okay, so if there are, you see, if we look here, if there are similar, this in similar rows in co-group, then those would result in an empty bag. Okay, all right. This is the resultant here. See, in when we co-group them in one, this grouped as this, one Robin this and this. Okay, so this is a similar thing. Can you see 1 comma Robin comma 22 comma 25 this? Okay, So if difference is there, then the output would come. Otherwise, this will come as a null bag, a bag having nothing. That is indicated here. Okay. And if you see the second one, here it is 2 comma Bob 23 this, and here it is 2 comma Jaya. So these are different. So this will appear. Okay, this will appear. And since you have written the sales emp underscore sales as the first one, so this is similar to your SQL operation, emp underscore sales minus emp underscore bonus. So the rows which are present in emp underscore sales but which are not present in emp underscore bonus, it is something to that minus operator that you've done in SQL. So that is how the output is there. So similar output here, if we dump here, would be in front of us. Okay, you can see the similar output. So I can share these files with you, or then you can just check these functions. Where we'll be using them would depend upon what type of query we get. Okay. So another quick poll, very simple one, I would say. I've launched the poll. You can answer it now. I put very easy questions in today's poll. Now we have 10 seconds more. 5 seconds. I'm going to end the poll now. So sharing the results, 88% of you are correct. Int float double long, for that size function returns 1. Okay. Still 4 of you are saying 2, 1 of you is saying 4. Don't know what you guys are doing. Okay, let's look for another poll if it's there. No, we need to wait for that. All right. So this is regarding your eval functions. Now let's have a look. Let's have a look at our first case study. Okay. Pay attention to it. You will be getting it as a machine exercise. I'll be sending, maybe I've already sent this file, or I'll be sending this data set to you. This is a data set, whatever name I'll give it to, movies underscore data or data underscore movies.csv. This is a CSV file, and it contains around 50,000 records. And what is there in the data file? The first one is the serial number. Okay. The second one is the name of the movie. The next one is the release year of the movie. Next is the rating of the movie out of 5. 3.9 is the rating out of 5. And the last column is the duration of the movie in seconds. Okay. This is the layout of our data set, the CSV file. And some 50,000 movie reviews are there. Okay. Exact figure is 49,590. Now what you need to do is, you need to do these tasks for this. This is what would be given to you, right? So the first thing is copy this file into HDFS in the root directory. Okay. Then load this file into a relation and assign a suitable schema to it. And then dump this relation and store this relation. These are the 4 basic operations with this. So we can have, we can see whether we have got this file with us. So let me look for it. So I do have a dataset-movies.csv file. Okay. This is the file on which we need to carry out our case study. All right. So if we can locate this file, say in our files section here, in our home section. So it should be here somewhere. Yeah, this is the file. I'll just double click on it. You can see it as an Excel file. This is the file. This is the data set. Okay. Being loaded in front of you now. Okay. So this is the first field, that is a serial number, then the name of the movie, and then we have name, then release year, I think kahan chala gaya. Then we have the rating, then duration, release year बीच में से गुम तो नहीं हो गया? A release year would be there, of course. Okay, so instead of viewing it as an Excel file, what we do is we can load it. So the first four queries that you see here, copy this file into root directory of HDFS, load this file, dump this, store this. So let's do each of these operations. I'll do it from the grunt shell itself. So I can use an fs here, fs hyphen put, and then the name of the file, dataset hyphen movies.csv, okay, and then the location, the root. Okay, if the file is already there, it will say a file exists. So what I have done, yeah, so this file already exists. Okay, if I need to overwrite it, obviously you can put a hyphen f as a force switch here, so it will now write. Okay, so we can see our explorer here, and what we can do is we can just open up another tab here and go to our web UI, and then we can browse the file system and we can locate the file here. The file would be there in the root, the first file, dataset-movies.csv. The size is 2.81 MB, right? 2.81 MB. ये size concept भूल तो नहीं गए, block size and number of blocks. So if the block size of our cluster is 2 MB and the file is 2.81 MB in size, so how many blocks for this file? Can somebody just tell me? Just a recap that you have not forgotten it. How many blocks are there for this file, dataset movies? Okay, 3 people have raised hand. Yes, Narinder?
Sir, 2 blocks.
Okay, good. So we can see here 2 blocks, block 0 and block 1. Block 0 is 2 MB and block 1 is the remaining 0.8 MB. Good, Narinder. Thank you. So we have already loaded this file into the root of the distributed file system. And now we can load it in some relation. So let me give the name as MOV and let me load it here. Load dataset hyphen movies.csv. Okay. Using big storage. It's a comma separated values file. And then I can give a name here as serial number colon int comma name colon char array, right? And then the year, so I can write here as year colon int, and then the rating, so I can give as rating colon float, and then the duration, so I can write here duration comma int. Okay, so I've loaded this file into the relation move. So when I dump this relation, you have a look on the screen, it will display all the data from the file, 49,590 records. Okay, so you can see here, and we have got null values also. Remember, when we are analyzing data sets, null values are bound to be there. For example, this movie My Hope America with Billy Graham, you see this movie, this has got no duration here, null. We don't know what's the duration. This file Barbie Life in the Dream House, okay, this is not having any rating. So we can have null values in any of the year of release could not be there sometimes, but usually in terms like ratings or durations could we have null values here. And if we store it, say store MOV into MOV, right? So you will see 49,590 records would be displayed on the screen. The number would be there that so many records have been written. You can see it here. Okay. So this see the case study, it's not that difficult. The first 4 have already been done. Store this relation, dump this relation, load, copy. So something like this you would be writing for your own data sets also. You will be picking up a similar data set from internet, and you will be first studying it properly, what is the meaning of each of the fields in the data set, and then you'll be writing queries like this, like the ones that I have written. Okay, so let's reach here. Now I'll be discussing 2 or 3 queries, and then I'll shift to the string functions. Okay, so kindly participate with me in these queries. Okay, most of you, some of you are not active, I know. I've noted the names, like we tried to talk to Navneet today, 263 roll number, she didn't respond. That means she's not attending the meeting. So I'm continuously noting this thing with me, that who is responding and who is not, and that is definitely going to play a big role in your internal. With you getting a 40% internal or not passing, and you getting a good internal, that's what, you know, this online teaching is. We need to judge by your reactions and by your responses, not just by your presence there, that your name is being indicated there, that you are attending the meeting. You need to be a participant in this meeting, right? So list the movie names and ratings of all movies having a rating greater than 4.3. Okay, list the movie names and rating of all movies. So you need to list 2 things, movie name and rating, for all movies having a rating greater than 4.3. So easy query is there. Let's see who can respond. You can raise your hands to answer, please. See, I'm not very much interested in discussing functions with you. You know, string functions. आप खुद पढ़ो string function क्या है, क्या arguments हैं. You can answer. What's the big deal in that? Okay. So just for your clarity, I'll just put this. I'm asking this query. I've highlighted it. Okay, so that you can see it and you can form your response. I think majority, why only 3 hands? Once again, the people who are answering, they stand a chance for a very good internal. Let me put this incentive very clearly, because I would be, you know, how I can judge what you are getting, how active you are, only by, you know. And what about the rest? Let's see, let's ask, Prince Agarwal. Are you there, Prince? Prince, are you there? Yes, Prince, please respond. Let's ask Yash Udewal. Yes, Yash.
हेलो यस
Yes,
सर
Yash. Prince or Yash dono aa gaye hain. My question to both of you, why you are not raising hand? You don't know the answer to this query. Both of you can answer.
Yes, sir.
यस सर
जब कर सकते हो तो क्यों नहीं हाथ क्यों नहीं खड़ा करते, क्या प्रॉब्लम है? You don't feel like, you know, you don't want to participate, क्या चक्कर है बताइए? You are good students. तो मुझे कैसे पता चलेगा ये बताइए? वही बच्चे बारी बारी हाथ खड़ा कर देते हैं, 5-6 बच्चे हैं. Okay, let's have an answer from Yash.
सर फर्स्ट वी विल यूज फिल्टर
Okay.
वी हैव
तो
loaded
भाई
the
या
set
फिर
in movie so we'll filter it that a equals to filter mv by mov by rating equal greater than that 4 point so 3
okay.
then we will use for each operator to project like c equals to for each generate for each a generate a movie name and so then next column that we want to display rating yes.
And then dump.
B.
Why didn't you raise your hand, Yash? What's the problem? See, it has come. Okay, movie name and the rating. So Yash, what do you think? How many records are there how many movies are there with a rating of more than 4.3? Can you make a guess? So let's not
Around
make a
250
guess. Okay, store A into, it was B, right? So store B into, say, rating. That's it. It will count automatically.
yes sir
178.
170.
Okay. हम guess देखते हैं आपके कितने अच्छे हैं. ठीक है. You can lower your hands, all of you. Thank you. Thank you, Yash. So this is where you start working with simpler queries. Okay. Next is list the movie names and release year of all movies released before 1999 and do not have a null in the rating. Read it carefully. You can write it on your copies and then we can answer them. List the movie names and release year. So two things needs to be displayed. Condition is they should be released before 1990 and they should not have a null in the rating. Okay, you've read the query. Raise your hands now to answer this. So let's see how many people try. I'm waiting for most of you to raise your hands, please. Yes, Ritika, answer.
So A equals to
Yeah.
filter MOV by
Hmm.
year less than 1990, comma rating is not null,
And
rating is not null.
rating is not null. ये आपकी condition हो गई. Okay. And then
For each A generate name and year.
how many do you think would be there in the result? Any idea out of 49,590?
Around 200 to
देखते
300.
हैं स्क्रीन पे देखते हैं स्क्रीन पे देख के बोलो. Increase your answer now. So बहुत लंबी लिस्ट है ना. So better to use that.
Yes, sir.
I think around 5,000. Let's see. 3,000 to 4,000 maybe.
Yes, sir.
No, not that much. 1463. Okay. For this. So one more query. Thank you, Ritika. One more query we'll go with. Let's pick up one more query here. Yeah, this one is good. List the movie names and ratings of all movies in which movie name contains the word boys or the word wild. ठीक है. जिन मूवीज में जिनके नाम में या तो वर्ड बॉयज कहीं भी आता है और वर्ड वाइल्ड कहीं भी आता है. ठीक है. Let's see who can answer this. This is the last query and then we'll do the string functions, right? Who's going to challenge this query? तो आपका फिल्टर ही चेक हो रहा है. अभी तो कुछ भी नहीं और किया हमने. So I'm waiting for your response. Ritik is the first to raise the hand. Ritik, Mridul, Yash. Very good, very good. So let's ask Ritik. Yes, Ritik.
So E equal to filter.
Wait. The screen नीचे कर लें थोड़ा. Yeah, filter.
Filter MOV by. So please display the query.
जल्दी भूल भी गए. लिखो ना उसको.
Name equal to dot star boys.
Okay. Movie by name equal to
Dot star boys dot star in
okay.
commas.
Is not correct. Let's ask somebody else. ठीक है Ritik, well tried. Let's
Okay, sir.
ask Mridul. Mridul,
Yes, sir.
your answer.
Sir, filter MOV by name
Hmm.
matches
Hmm.
comma
Hmm.
dot star voice dot
कैपिटल में लिख के देखें, बॉयज डॉट स्टार
and
और
matches or name matches while
लगता है तुम्हें इसका कुछ आंसर बनेगी बात कुछ? ये तो कह रहा है कुछ प्रॉब्लम है।
सर वो मैचेस के स्पेलिंग गलत है।
गलत कर दिया मैंने? अच्छा, वेरी गुड। सो MATC अब हो गया ठीक? ओके, तो इसको क्या करें अब? प्रोजेक्ट क्या करना है?
for each age
क्या प्रोजेक्ट करना है? मूवी नेम्स एंड रेटिंग। सो नेम comma rating. Let's hope that we can get some answer here, what Mridul is suggesting. कोई भी नहीं आई, 0। इसका मतलब है कि केस का कुछ प्रॉब्लम है ना?
yes
एक बारी केस चेंज करके देखें थोड़ा, ये प्रॉब्लम रहती है तो उसका कुछ इलाज है हमारे पास। अभी अगले 10-15 मिनट में देखेंगे कि इस तरह की क्वेरीज को कैसे हम उससे कर सकते हैं। सो इसको ऐसे लिख देते हैं लोअर केस में, ठीक है? फिर ये कर लेते हैं और फिर डंप कर लेते हैं। लेट्स होप दैट वी गेट सम आंसर्स हियर, or if not then somebody can be telling us what is the problem. Yeah, we get it now. So it was like, you can see, right? Let's see whether we are getting this. अब देखो इंटरेस्टिंग क्या चीज है इसमें, है ना? see wild how it is coming here, anywhere bewildered के बीच में भी wild आ रहा है. Can you see all of you? This is the beauty of analysis. Okay, so I said boys and wild. So wild कहाँ आ रहा है? Bewildered के बीच में आ रहा है. That is why this row has resulted. Okay, see wild is coming here in wilderment. So that is how it goes. Okay, so you must narrow down your search filter. Okay, so good answer, Mridul. You can lower your hand. Thank you. Okay, let's move further ahead with our string functions. Very interesting. And the problem that we had in the last query, we can resolve it by using one of these string functions. Can somebody suggest? The list is there in front of you. The problem of we wrote it in uppercase, in lowercase. So how can we solve that problem? From which of these functions listed on screen can we solve it? The answer is very easy. Mridul again wants to answer. Okay. Yes, Mridul.
so lowercase first
So
of all
we can use lower and upper. A better choice would be equals ignore case. When we are matching two strings, okay. So we are writing name matches this. So we can use equals ignore case. I'll be using it after some time, right? We can use this function equals ignore case. So let's discuss the functions one by one. Ends with, okay. So this would test whether a string ends with something or not. Okay. For this, again, we'll come back to this movie review. Again, I'll shift to my emp relation. Okay, so I'm going to dump emp here in front of you, and I'm going to discuss with you the ends with or starts with, right? What's the first one? Ends with, starts with. We'll discuss this now. So maybe we can find, display all records in which job ends with salesman. Okay, job ends with salesman. What should I write here if I want to answer this query using this function ends with? जिसके जॉब में एंड में मैन आ रहा है, right? मुझे वो चाहिए records. Okay, so I can use a filter here. A is equal to filter M by ends with job comma man. See, this is how we can use ends with. See, ends with, starts with. If we see the nature of these functions, please have a look at it. The nature of these functions, just have a look at the nature. These are Boolean functions. Okay, you're testing something, right? So they will either result in true or they will result in false. So you should be using them with the filter always. Substring is going to return a string. Equals ignore case, again a Boolean type. Index of will return something. Last index of will return something. LC first will convert. UC first will convert. So there are certain conversion functions are there. Certain functions are there which are returning some values, and certain functions are there which are giving you a Boolean answer. So ends with and starts with are giving you a Boolean answer. So is this equals ignore case. So if I use this, is this query fine? Will it return the salesman as the job? I'm saying filter M by, I'm comparing two fields. I'm comparing the job field with the man, in single quotes, capital man, right? And I'm saying that the job, if in the end of the job the word man is there, then that should be filtered. Okay. And if I dump A, I should be seeing all the salesman records. Fine. Okay. And obviously this is case sensitive. If you write it like this, then you will see no records. So we don't see any records because the case matching is not there. Similarly, what we can do here is we can work with the starts with, right? So we can say all the names starting with, say, S. How many are there? We can count. Smith, Scott, 2 are there. Okay, so let's use this starts with. And we can write here e name, and we can write here S. So this query is, I need to filter all those records in which the name, the e name, it starts with S. Okay, and if you dump A, you will see Smith and Scott. Right, this is the usage of this. Now let's move further. A substring, this we have already used. So in a substring function, you provide a string from which you need to extract the substring, and you provide a starting index. The starting index in a string is always 0. Right, so you may mention any starting index, but it starts from 0. And stop index, obviously you need to see, right? So let's write here once again, say, it's easier to see the records first, and then we'll apply these functions on our movie data set also. So maybe I can extract something from the job. Okay, let's extract something from the job. So filter emp by, I'll use substring from job. I'll ask this from you now, the output. Okay, you'll be raising hands for this. So I'm writing here job. Okay, and then I'm saying here, say 1 comma 6. Just lost it. Emp by some substring, say job 1 comma 6. I wrote the field name in capital. Okay. where I'm going wrong, can you please suggest? Am I using the function name correctly? Let's have a clear screen. Can somebody tell me what is the problem? Say I've written this, it's not working. How do we analyze what's the problem? This would be a very good answer if somebody gives it. Just think it over, that why it is not working. Ritika, Yash, Prince, Narinder Pal, Rohit Kumar Singh, all good students, Pradul. Why this is not working? I'm writing everything correctly. I would expect one answer from any one of you, and then I'll answer it on my own. Okay. Yes, Narinder.
Sir, maybe it's extracting from the job itself.
Okay. Then what
तो
needs
उसकी
to be
लेंथ
done?
तो उसकी लेंथ ज्यादा है, हमने
No.
1 to 6 दी है.
नो, हमने क्या बोला है, जॉब में जो जॉब फील्ड है उसमें जो फर्स्ट इंडेक्स है, फर्स्ट इंडेक्स से लेकर सिक्स्थ इंडेक्स तक आउटपुट आएगी. सिक्स्थ इंक्लूड नहीं होगा सब स्ट्रिंग में, जो फाइनल इंडेक्स होता है दैट इज नॉट इंक्लूडेड. That is not the problem, Narendra. Now look carefully. I told you that there are certain functions which return boolean values. उनको filter के साथ use करते हैं जो boolean return करते हैं, because they would end in true or false. Now this substring is returning something, so this needs to be used with the projection.
Okay.
Right? ये कुछ return कर रहा है ना, तो इसको project करना पड़ेगा. So for each what m generate, that's it.
Okay, sir.
Right? Got it? I hope all of you have got this thing, that functions which are returning something, they should be projected for each generate, right? Those which are returning true or false boolean values, they should be used with filter. Okay, so if we dump here, let's see what we find. Job में से starting from index 1 and up to index 6 but excluding index 6, you can check it. So clerk में C 0 पे है, L 1 पे है, right? You can check 1 2 3 4, clerk में उतना ही है, right? Salesman में you can check correctly. Salesman में A is at 1, so 1 2 3 4 5. I said till 6, so 6 is not included. See how it works. The starting index, whatever it is, it will start from there. Ending index 1 less. If it is 6, it will be up to 6. 6 not included. If I write 66 here, will it work? Somebody can give me a quick response before we see it on the screen. If I write here job 1,66, will it work? Yes or no? Similar to your Python and your SQL, substring functions. देखो वर्क करता है कि नहीं, सेम आउटपुट आती कि नहीं, देखो. Right? No problems, because you are mentioning the final index. Even if it is not there, no problem. Yeah, if you give the initial index as incorrect, then problem would be there. If I give it something like 66, 78, okay, so there is nothing. Oh, sorry, this will go, and then if we dump, you see what the output is there. Let's see whether it gives an error or a null output. So nothing is there. There is no index 66, so no error is here, right? Okay, maybe in Python it gives index out of range or something like that, but here it is not finding this index 66 to begin with, so null values are there. Okay, I hope you understood this. Let's go ahead. Next is equals ignore case. So two strings, it will return a boolean value if the two strings they are matched without taking the case into account. So true or false it will return. So the problem that we faced some time back, let's now address it. The movie The Boys and the Wild. Let's go here. This was the problem. Now this query didn't return any rows. Okay, so you can now write here by, filter move by, you can write here, let's try this, equals ignore case name. Here it won't fit actually because this is a expression, right? Yeah, here we cannot use it by this. So one way would be, maybe we can use a lower function or an upper function here. You can convert this into upper name matches, right? Or we converted our name here into uppercase, right? No, into lowercase, sorry. It's already in uppercase. We convert it to lowercase. See, in our data set, the names are in uppercase, okay? But then this search would be restricted because we saw wild comes in bewildered also. So there the B is capital, wild is this, okay? So if you need to find everything, you can apply a more or conditions here, okay? So something like this. This will work. This will result in some queries, okay? For this, our example, let's use a filter on our M table. Now the M table is gone. Yeah, for each M, uh, let's use a filter here. Yeah, filter M by equals ignore case job and then the second string. Okay, I've written this query. Can somebody tell me what it will return? Will it return all the salesman record? Yes or no? You see, it will match this job with man. Now this, okay, sorry. Uh, we are mixing two things here. I need to write full salesman. So it will match this job with salesman, okay? The salesman value in the actual data set is in capitals, but this will match by ignoring the case, okay? So it will return all the rows. It will return all the rows here. So case won't matter here. It will return all the 4 salesman records here, or whatever is the number. Right? I hope you understood this. I'm using equals ignore case. It matches 2 strings ignoring the case. So I'm matching job in the table, in the relation, it is in uppercase. I'm matching it with the lowercase. But the function that is being used is equals ignore case, which ignores the case. So quickly, let's move ahead. Index of. So if we need to find the index of some character in our string, okay, index starts from 0, remember? So we can use this index of. So let's have a quick working with this index of. So index of is going to return something, so we need a projection. So I can write here index of job, and then I can mention something here, say R. What is the other argument? Other one is the start index. Okay, fine. So I can mention here start index as say 2. Okay. So what will this return? Can somebody answer? What is this going to return? Please answer somebody. It will check. I'll first list, okay, so that you can give me a good answer. I'll first dump M so that you can see the records, and then you can answer this query that what tuples would be returned. That is the only way we can learn these functions. Otherwise, theoretically you can read and you can learn. Okay. So I've written this query. Looking at the job column, you can see the index of R starting from the second index. Okay. Which records would return? How many and which records? So I'm waiting. You need to concentrate, obviously. You need to see on the screen and answer, please. If none of you can answer, it's a problem. That means you are not concentrating. You need to generate that what is the index of R in the job field starting from second, index. The first index is 0. So clerk में C is at 0, L is at 1, E is at 2. So 2 के बाद देखना अपने R किस किस में आता है. So that's very easy. It will come in clerk. It will come in manager, right? It will come in, yeah, now some people are trying to answer, but that's a slow response. I take it as a slow response. Okay, Ritika can answer.
Yes.
How
So
many
it will
records?
return. So it will return all the records.
सब में आ रहा है R?
So जिसमें R नहीं होगा उसमें -1 maybe.
Okay.
It's index of.
So you are one step ahead. You know if something is not returned, then -1. So if no match, if no index is found, then -1. So let's see this. Let's dump A. You'll see the numbers, okay? So जहाँ जहाँ नहीं मिला वो आपने देख लिया है. So just to be sure, what you can do is you can generate the job also here.
Yes, sir.
You can generate the job also. Then you can dump. Query, I'll put it on screen. Once the answer comes, I'll put the query on screen. This was the query we used. We're looking for the index of R and job. So clerk में R जो है, and we are starting from the second position. Okay, so in you can see maybe some problem area is there. In president you can see. In president R is coming. See, but we are starting from second index. We are starting from 0, 1, 2, PRE. We are starting from E. It will look after E where R comes. So if it is not coming, it will return -1. That is what index of is. Similar to your Python index of. Then we have got the last index of. Okay, last index of. Okay, let's see how we can work with it. इसी को कर देते हैं. I suppose we should write it like this. We'll check. Should work with 3 arguments. चेक कर लें arguments 3 हैं कि 2 हैं. Just a second. I need to give 2 arguments only. This name is problematic, I think. Let's try a full. Somebody is raising hands. Somebody is using some. Okay, Ritika, how to write it?
So there is underscore in last, underscore index, underscore of.
Yeah, I thought of underscore, but I don't understand. Some functions are like equals ignore case was like E and I and C capital. So okay, fine. Thank you, Ritika.
Yes, ma'am.
Generate
Yes.
job comma last index of job R. Okay, and this is interesting. The output. Have a look. Somebody needs to explain this to me, right? So output is coming in front of you. We are looking for last index of R in job. Okay. तो एक तो इसकी पहले डेफिनेशन देखें लास्ट इंडेक्स ऑफ की सो दैट वी कैन लेट्स सी इट्स डेफिनेशन राइट लास्ट इंडेक्स ऑफ remember returns the index of the last occurrence of the character in a string searching backwards from a start index. Okay, see the definition: returns the index of the last occurrence of the character in the string, searching backwards from a start index. So you see this, we start from here, so R is coming here. This R we are interested in. अगर एक R इधर भी होता तो उसको ignore करना था. So this R we are interested in, it's here. We are searching backwards, okay, but the index would be counted from the front. So the index is 0, 1, 2, 3. Okay, in salesman it's not there, so we don't have a record which has 2 R's, otherwise we could have checked. Do we have something in the name? Let's check the name so that we can understand it properly. We'll have a 10 minutes extended class, please. Huh? One poll is there and I need to discuss a few more things. Let's look for something which can help you guys. Adams, James, no duplicates are there. Okay, let's look for this Miller. Okay, Miller is having 2 L's in it, right? Let's check this. For each M generate, let's use ename. Please focus, all of you. Just 10 minutes more, right? So I'm looking for last index of L in ename. So I would be interested in the record Miller because there are 2 L's. So the answer could either be 0, 1, 2, 2 or 3. So let's see what's the answer in case of Miller, whether it's 2 or 3. So last index of would say, what did we do? We dumped M. So dump A. I'm going to dump A and I'm going to see the last index of L in Miller. Should either be 2 or 3. So let's check. So it's 3. And it's good also because it is looking from back and the index is counted from the start. So it starts from R, E, L. It finds L. Now L index from the starting is 3. Right? So that is about this last index of. All right. One poll related to this very thing only. The poll is there in front of you. Ending the poll in 5 seconds now. All right, I'm going to end the poll now. Sharing the results with you. The correct answer is last comma backward. Okay, it returns the last occurrence of the given character in the string, searching forward from the end of the string. ठीक है, पीछे से सर्च करना शुरू करता है और लेकिन जो इंडेक्स काउंट होता है वो स्टार्टिंग से होता है, राइट? सो इट इज 80% of you are correct. Some of you are not answering properly, so that's okay. So then we have certain more functions. You can see LC first, UC first. The names itself, they are suggesting that what these functions are going to do. So we'll continue this discussion in the next class. Okay, so I'm going to end this class now. Thank you very much.